Hello. What you're looking at is a GQF incubator. Some refer to it as a Sportsman 1502 1200 series. These have been around for several years. This one is a basic 3-rack incubator with an automatic turner. It would have the optional hatching basket that would go in the bottom. And those of you that are familiar with these, as you can see with the little yellow sticker, this is the 3255 electronic thermostat excuse me, that comes with these incubators. These are probably their more accurate incubators. The old ones had the 2 wafer type thermostats, which were not really that accurate. This one has the GQF supplied water pan. As you can see, it has the wick inside. I also have the water reservoir up top with the tubing that connects. It is gravity feed into this pan with a float control so that you have a constant level of water in the incubator. Therefore, you don't have to open the door and release a lot of heat, and it keeps everything pretty much on an even keel. You can see here that I have just an aftermarket humidity temperature gauge, and you can see that the temperature inside on the front shelf at the top is 101.8 at about 62% humidity. Now, some may say, well, 101.8 is a little bit too warm to incubate chicken eggs. You can see here I've got about 120 chicken eggs in the incubator currently. The problem I've had with this incubator over the last several years, I've hatched several chickens in it with pretty good success, but I always have a lot of eggs that either hatch late, sometimes they hatch too early, and through trial and error I have figured out that it's because I am not getting a uniform temperature flow, and the way these are designed, just the way GQF builds them, you can see over on this side it has the front hole here where I have an electronic thermometer probe. The front hole is for a dry bulb. Then this back hole that I have blocked off right here with a piece of tape is for a hygrometer or a wet bulb thermometer that would go through and with a wick on it into that water pan to give you your wet bulb reading, so that between the two you could obviously calculate your relative humidity. You can see inside I have one of the little Brenzy thermometers here reading at 100.9. Now that's about 1.5 feet in front of the actual heating element and fan in the top of the case. What I did to remedy it after some research is I found this little ETC electronic temperature control made by Omron. It has a fuzzy logic type computer temperature controller. It has DC output is supplied with AC current, but it has some DC outputs on it, and it also has some built-in relays that control these 2 piezo buzzers. These are typically about $3.60 a piece from Radio Shack, and they're nothing more than a 12-volt piezo alarm. What I have done is wired them into this temperature control, and I'll show you here just through the programming. You can see that I have my high limit alarm set at 100.5, so that if it gets that temperature or above, I'll get a piezo alarm letting me know that it's too warm. If it gets down below 98, I'll know that it's too cool in the incubator. If you'll notice the temperature, the bottom in the green is my set point. I have it set at 99.5. You can see that the actual temperature right this minute is 99.4. If you'll notice here, this is the light indicating that current is right now being supplied to the heating element. You just saw it go off to keep this at 99.5. This little unit has an auto tune, which allows through the auto tune system, once you set it to auto tune, it will program itself for about 10 minutes by experimenting with different timing and load resistance on the heating element in there, so that it's able to determine exactly what the optimum amount of current and the time frame of that current that's needed to send to the element to keep the temperature precisely at 99.5. Now, I'm sure some of you are wondering, well, now you're showing 99.5 there, and up here on your little Brenzy you're back at 101.1. Well, just by the nature of this incubator, obviously the top of the incubator has got to be a little warmer than further down on the incubator in order to accommodate for the heat loss in the unit, and generally your forced air type incubators are much more uniformly heated than a still air incubator. You don't have the layering of the heat. So what I have done, this unit, this little ETC here by Omron, it also has a hookup on it that will allow you to wire in something like a J or an N K-type thermocouple, which is much more accurate than just a standard temperature or thermostat on this this electronic thermostat that's supplied with it. And it also allows the use of an RTD, which is a resistive thermometer. It measures through resistive current the temperature, and this is able to translate that into the actual temperature read. It hooks up through this probe, through this wire, and I've drilled a hole in the side of the incubator, and I have the probe laying directly on top of my second rack of eggs. So the temperature that is reflected here on the ETC unit display right now is dead on 99.5, so it really doesn't matter what the temperature is in the top of my incubator. This is the temperature of the egg, and 99.5, as we all know, is pretty much the optimal temperature for incubating a chicken egg. I still have the original wiring and everything hooked up for the automatic turner, just like GQF designed it. All I did was drilled a hole here, cut the wires loose from the heating element, and ran them out so that I could tie them into this little box. The box here is a gray conduit junction box. It's about a $7 box at Lowe's or Home Depot, and I just cut the cover of it out and mounted this little ETC in there. The ETC is supplied with 110 volts, and it has a DC output that runs down to the bottom to a solid state relay. And as you can see, the relay here is supplied with DC current on this side and AC current on this side going to the element. And during the entire time I've been talking to you, you'll notice how constant this thing is able to maintain the temperature of 99.5. It occasionally will go to 99.4, 99.6, but basically throughout a 24-hour cycle you will not have more than a 1/10 of a degree variation in this temperature, so long as you don't open the door or fool with the thermostat setting on it. The big advantage, what I have found since installing this, the last several times I've set eggs, I'm getting about a 98% hatch rate. I mean, it's inevitable that regardless of who supplies your eggs, if you're getting your own eggs, if you're taking them out of the nest today, or if you accumulate them for 2 or 3 days before setting them, you're going to have a few eggs that are just not going to be fertile, or they're just going to be bad eggs. I mean, they just, for some reason, they're not going to hatch. But I have pretty much overcome the temperature variation problem that many of us experience when using these types of incubators, that being that this is just a much more sensitive temperature control than this type that comes with the unit. Plus you have the added benefit here of being able to read a digital readout versus you know, 1/4, 1/8, 1/16 of an inch turns on the little knob here, where you have to keep playing with it up and down and come back in 15 minutes to check it. The fuzzy logic alone in this unit makes it foolproof. All you have to do is, in the green, as you can see, is set it to 99.5, let it run its auto-tune program, and after about a 15-20 minute period, assuming that your incubator has already warmed up sufficiently and all the metal and wood and stuff in it is at operating temperature, this unit will keep this thing almost dead on 99.5 in a 24-hour period without fail for the entire duration of the incubation period. The RTD that I referred to, which is a little platinum resistive, this thing runs about $55 from a company called Omega. This unit is made by Omron. It runs you about $225, and some might say, well, that's a lot of money, but if you're in the business of raising purebred chickens, pheasants, hatching quail, this right here is the most critical element, your temperature and your humidity. As long as your eggs are getting turned and your temperature stays the statistics show that a ½ degree fluctuation per day in your temperature on your incubator can add or subtract as much as 5 hours to your pipping and hatching time. What I have found on this is that if I keep it set on this unit at about 99.5, nearly 98% of my eggs will begin pipping at 20.5 days, and by the full 21 days later on these chicken eggs, most of what I am going to have hatched is out of the shell. They're dry, they're ready to be put into a brooder, and I simply discard the other eggs. If you're in the business of raising purebred stuff, you don't want to get into the habit of peeling chickens out of the shell and them sticking to the shell, bloody navels, that type of stuff, and this eliminates that. But just again for a quick review, this is a Fuzzy Logic electronic temperature control from Omron. The probe is made by Omega. It is an RTD type probe. These two units together run you about $300, and if you already have the thermostat, or the incubator rather, it's just a simple matter of cutting a couple of wires and tying everything back in, and you wind up with a real good setup. And again, this shows, if you look last time, I'm at 101.8 degrees on my top shelf, but down here where the eggs are located, and I'll see if I can show you that probe. You can see the probe right there hanging right above my eggs. The temperature on the bottom of that shelf is 99.5. So we really don't care what the temperature is up here. There's no eggs up here to get overheated. Down here is where we need our critical temperature control. That's exactly what this unit is doing. I'll get back on some more video later on as the eggs start pipping and hatching, and we'll see how well this works out. Thanks for taking a look.